Okay, this video is going to be talking about chords. Okay, chords. What a chord is on a circle, what it looks like, some properties of what a chord is, and how it can help us solve some problems. Okay, so first of all, I'm going to draw a circle. Okay, so here's a circle. What is a chord? Okay, I just messed it up. Okay, so what is a chord? I'll make this a little bit bigger. Okay, so this is a circle. What is a chord? A chord is a line or a line segment that goes from one side of the circle to the other side of the circle, where the endpoints of the chord or of this line segment are on the circle. It has to be on the circle. Okay, a chord can go any which direction. It can be longer, it can be shorter, it can go through the center of the circle. It does not matter. Okay, they can intersect each other. They can go anywhere. Okay, an example of something that's not a chord. If it goes from the edge of the circle or a point on the circle to just some other point that's not on the circle. This is not a chord. Okay, not a chord. Chord has to go from one side to the other. So this is what a chord is, or this is a bunch of examples of chords. Okay, so how can we use that, or what are some properties that can help us solve some problems? Okay, so the first thing is, if chords are equidistant from the center of the circle, then they are going to be congruent to each other. And this is always a true statement. Okay, so what does this mean? So if we have the center of the circle, this point O right here, the center. Okay, if the distance from the center to each chord, from O to O to E, and from O to F, let's even make up a number. Let's say these are both a distance of 5, okay, 5 inches maybe, I don't know. If they're both the exact same distance, then the entire chord AB is going to be congruent to the entire chord CD, just right here. Okay, the entire chords are congruent to each other. Okay, we also have the converse of this statement. The converse says that if the chords are then congruent, then they have to be equidistant from the center. So you can go backwards also. So what does this look like as an example? Okay, so this is an example on our worksheet, number 4. The question is asking for x. What is x? So first of all, I have this section right here, which is 2.5. This section, which is 2.5. So the entire chord going from one point on the circle to another point on the circle, the entire thing, add them up, 2.5 plus 2.5, we end up with 5. 2.5 plus 2.5 is 5. So this whole chord is 5, and this whole chord is 5. And again, from what we just said, if the two chords are congruent to each other, that means they have to be the exact same distance from the center. Meaning if this, from this chord, the top chord to the center is 2, the bottom chord to the center also has to be 2. So x is equal to 2. Another question. Okay, so on this one, it goes from the center to this chord. So it goes from the center to this chord. And we know that these are congruent to each other. We want to find x. These little congruent marks mean that this one is 3.5, this one is 3.5. Okay. The 2 hash marks mean that this section is 5, so this section over here with also 2 hash marks has to be 5. So the entire chord, 5 plus 5 is 10. So what does this entire chord have to be? Also 10, so x is equal to 10. Okay, there's another property. It says in a circle, a radius that is perpendicular to a chord bisects the chord and its arcs. Okay, so what does this mean? Well, if a radius and a chord are perpendicular to each other, perpendicular means they intersect at a right angle. So if the radius and a chord make a right angle, then that means that the chord is bisected or cut in half. So this part, AE, has to be congruent to segment EB. And its arcs are also bisected, meaning the arc AD is congruent to the arc DB. These are congruent to each other. You can also use a converse, again, where you flip it. So if you have a circle where the radius is bisected, or the radius bisects the chord, then it has to be perpendicular to it. So if these sections are congruent to each other because of an intersecting radius, then they have to be perpendicular. It has to make a right angle. So what does an example look like? So there's actually a couple pieces in this. So first off, we have a radius and we have a chord, a radius ZH and a chord CD. Okay, we can notice that they intersect at a right angle, meaning they are perpendicular to each other. If they're perpendicular to each other, that means that the segment CF and the segment FD are congruent to each other because we said the radius bisects the chord. We also know that the arc, CH, has to be congruent to the arc, HD. Okay, so now we're going to look up here at what we're given. It says the radius of circle Z is 6. Okay, so some radius, whatever it looks like, I'm going to draw it up here. This is 6. If you notice, ZH is also the radius. It's also 6. Okay, I'm not going to draw it though, and you'll see why in just a second. This says ZF is 3. Segment ZF is 3. If it tells me that this is 3 and the entire thing, ZH is 6, I can say 6 minus 3, and FH has to also equal 3 because 3 plus 3 equals the entire radius, 6. And that's our first answer, which is actually number 8. FH is 3. Then it tells me that the measure of arc HD is 60 degrees. If HD is 60 degrees, it's congruent to CH, so CH also has to be 60 degrees. Number 5 is asking for the measure of arc CD, from C all the way around to D. Well, what does this equal? Well, we have CH is 60, HD is 60. Add them up, 60 plus 60 is 120. Next question, number 6, is actually asking for the measure of an angle CZH. Now, this one's not drawn for us, but C to, oh goodness, let's try this. C to Z. That wasn't that bad. To H, that was pretty bad. Oh, erase the whole thing. To Z to H, that's about the best I got. I'm going to find this angle right here. So a couple lessons ago, we talked about how a central angle, which CZH is a central angle because the vertex is at the center, is going to be congruent to the intercepted arc. So the arc CH is our intercepted arc. If it's 60 degrees, that means our angle is 60 degrees. Okay. Last one is we want to find the segment CF. This one might not be as clear to you, but we can first notice if this is a right angle, this one of course is also a right angle. And again, 90, 60, the inside of a triangle. All three of them had to add up to 180. Some people can already see quickly this is going to be a 30-degree angle because 30 plus 60 plus 90 is 180. We have a 30, 60, 90 triangle now, so we can find CF by looking across from the 30-degree angle. I'm going to go to write up a little table up here. Across from the 30-degree angle is the length of 3. We're looking for this right here across from our 60-degree angle. That's what we want, side across from 60-degree angle. And we, on our formula chart, or if we just remember, across from the 30-degree angle is what we consider x. Across from 60 is x square root of 3. So what does this do? What does this mean? This means that we have to multiply our x by square root of 3. X times the square root of 3. Our x is 3 in this case, so plug this in. 3 for x, so 3 square root of 3. And this would be across from the 60-degree angle right here. So 3 square root of 3. And that is the distance CF, 3 square root of 3. You could also do Pythagorean Theorem to get a decimal answer, or you can plug this into the calculator and get a decimal answer. But this is more accurate, and it's a little bit easier. We could say that C to Z is also a radius, and it tells me up here that the radius of a circle Z is 6, so this is 6. Then we can say 3 squared plus 6 squared is equal to x squared. But again, that would be a little bit more work. Okay, the next question. Another example. This is actually combining a couple things together. So if we first look, the segment O to G is a radius, and A to B is a chord. If a radius and a chord are perpendicular to each other, the chord is bisected, and its arcs are bisected. Okay, I'm going to start with just that. We also see, I'm going to skip this first thing first. It says AB, segment AB is equal to segment CD. So AB is equal to CD. But I don't know what they are yet, so I'm just going to leave it just like that. It does say that CD is 8 though. So if CD is 8, what is AB? AB is also 8. And again, it's been cut in half. So AE and EB are congruent to each other. They have to add up to 8. So you can just divide 8 by 2. So you get ABE is 4 and EB is 4. Similarly on the other side, since this is 8, they intersect at a right angle. These have to be congruent. These arcs have to be congruent. The whole thing is 8. Each section is 4. Okay, so we can find segment AB. AB is 8. We also can find segment FD. FD is 4. Then we're going to go back up to the top. What's given to us, it says the measure of arc GB is 51. So GB is 51. And AG is 51. Meaning also HD is 51 and CH is 51. So the arc AB is 51 plus 51, which is 102. Arc CD is 51 plus 51, which is 102. Next question, this is on our homework, it's number 16. It's asking us to find the entire chord X. So how do we do this? The first thing we notice is this little segment is 6. It tells us it's a right angle. These are perpendicular to each other, meaning the chord is cut in half. Each of these are congruent. We also know the radius right here, or the hypotenuse of this right triangle, is 12. Since I know two sides of a right triangle, I can use Pythagorean Theorem to find the third. 12 is going to be my C across from the right angle. It's the hypotenuse, so it's all by itself. I'm going to say 6 squared plus, I'm actually going to use y squared is equal to 12 squared. I'm going to use y because x is this entire distance. So just this part of this triangle I'm going to call y. 6 squared is 36 plus y squared is equal to 144. If we want to solve for y, we got to get rid of this 36. We're going to subtract 36 on both sides. We get y squared is equal to 108. Then we want y by itself. To get y by itself, we got to get rid of the squared. To get rid of squared, you take the square root. So y is equal to the square root of 108, which is 10.4. So this segment right here is 10.4. But again, we want the entire chord. So to find x, the whole chord, this is 10.4, this is 10.4. Add them together, 10.4 plus 10.4 is 20.8. The next question is similar, but it looks a little different. Last time, we were given this segment right here, the hypotenuse of this right triangle. This time we're not given it. We don't know what this is. But if you look very carefully, our x, what we're trying to find is the radius. Well, isn't the segment we just drew in green, this segment right here, isn't it also the radius? It goes from the center to the side of the circle. So this is also our x. Now we have a right triangle, because if this is a right angle, this is a right angle. If our entire chord is 22, the chord is split in half, meaning this part has to be 11 and this one has to be 11. The height of this triangle is 6. We can solve it by Pythagorean Theorem. So we have 6 squared plus 11 squared is equal to our hypotenuse, x squared. 6 squared is 36. 11 squared is 121 is equal to x squared. 121 plus 36 is 157. Looks kind of like a 2. I don't know what I was doing there. 157 is equal to x squared. To get rid of your squared, I'm actually going to do it this time. I'm going to write it down. Take the square root of 157. So the square root of 157 gives us 12.5 if you round to the tenths place. So that would be our x. And that would be our radius of this circle. Okay, we have one more property on a triangle that deals with chords. In this case it says congruent chords intercept congruent arcs. Now what does this mean? If we have a chord AB and a chord CB, if they are congruent to each other, their intercepting arcs, for AB it would be the arc AB. Well, I don't know what that was. Let's try that all over again. A wow. One more time. Good enough. AB, this arc, you know what I should do? I should actually highlight. Highlighter. This is gonna be way easier. Oop. There it is. If this chord, AB, is 150 degrees, that means that this chord on the bottom, CB, a lot better, CB would also have to be 150 degrees. So let's look at an example. Okay, this one's quite an interesting one. The first thing I want to notice here is nowhere in our instructions does it say that AC is a diameter. Nowhere in our instructions does it say that point O right here is the center. Normally, I could look at a circle like this, if I know that AC is a diameter, and say just this part of the circle is half of it, which would be semicircle, so I could say 100 plus 80 would give me 180 degrees for a semicircle. In this case, I cannot do that. Why? Again, because I don't know that AC is a diameter. I don't know that point O is a center. If I knew either of those things, then I could do that. But since I don't, I need to try to use something else. So this information says given AB is congruent to DB. AB is congruent to DB. I'm going to actually put these little hash marks on there, symbolizing that they're congruent to each other. Again, if two chords are congruent to each other, I'm going to use a highlighter again. AB, their included arcs, are also congruent. So if AB is 100, that means that DB has to be 100 degrees. But I already know that DC is 20, so I'm going to say 100 degrees minus 20 degrees and get 80 degrees for CB. It did turn out that CB was 80 degrees. It happens to be like that. And because it's 80 degrees, it does tell us that AC would then become a diameter. But at the beginning of the question, we didn't know that, so we could not use it. Okay. Next question says solve for x and find the arcs AB and CD. Okay. Okay, so the first thing we're going to notice is this arc AB is congruent to the arc DC. These two are congruent to each other. And what does that mean? That means that the arc AB is going to then be congruent to the arc DC. I'm going to try that one again. DC. Okay. Okay, so if these two arcs are then congruent because the chords are congruent, I can set up these equations, or I can set up an equation saying that 4x minus 10, this arc AB, is the exact same or equal to the arc DC. So I'm going to write an equation. 4x minus 10 is equal to 2x plus 34. Again, because the chords are congruent, their arcs also have to be congruent. Okay. Now this is just a simple two-step algebra equation. To solve, first I'm going to move my x's over. I can move 4x over or 2x over, it doesn't really matter. I'm going to choose 2x. I'm going to subtract 2x from both sides. 4x minus 2x is 2x. We keep our negative 10 and we keep our 34. These cancel. Okay, now I'm going to get rid of this negative 10. I'm going to add 10 to both sides to the opposite, so these cancel. We get 2x is equal to 44. To solve this, you divide by 2 on both sides. We end up with x is equal to 44 divided by 2 is 22. So that's what x is. X is 22. It says to find the arcs then, AB and CD. AB and CD. Well, how do I do that? Well, AB is 4x minus 10, but I know what x is now. So I'm going to plug in that equation. So 4 times 22 minus 10. 4 times 22 is 88. 88 minus 10 is 78. So the arc AB is 78 degrees. I'm going to write it down here, 78 degrees. So what is the arc CD? We said before that if the chords are congruent, that means their arcs are congruent. So AB is 78, so CD or DC also has to be 78 degrees. Is there a way for us to check our answer? Sure there is. If we plug in x, 22, into this equation, it should give us 28. So I'm actually going to do that. 2 times 22 plus 34. 2 times 22 is 44. 44 plus 34 is 78. So hey, yay, we did get the same answer. Okay, so that's it for some examples on chords. Good luck.